today's lecture we will study the polynomial regression. Okay, so asa na to siya magamit? Okay, so say for example, you have these data points. Okay. Now, when you look at these data points, there's a big chance that we cannot fit linear line or linear regression. Why? Because we have observed that there is curvature. No? Actually, we can use, but it will not give us the best representation for this data. So what we're going to do is we will use the polynomial regression. In this case, we'll try to fit a second order degree curve. Okay, so again, we will still use the same process for linear regression, but this time we will represent these data points as a quadratic equation. Okay, a1 x sub I, okay, plus a sub 2 x squared plus the error. Okay, anong plus the error man? Say for example, again, kaning a point. So this is your x and this is your y. Okay, so kaning a point will be represented by a point on this curve. Ano man kay kani naman nga curve atong gamiton to represent the entire data. So naa kay error karon na. So mo ni na plus kay. Again, therefore, want to get the error. The error is just y minus ani tanan. AO minus A1x minus A sub 2 x squared. Now, we get the total error. Again, this is just a sub r, or the sum of the sub r. Now we get the total error, so just sum it. So may maning summation of y minus AO minus A1 minus A sub 2 squared. Again, from 1 to n. Then, to make the error small, ito is lang a square. Okay? And after getting the square of the error, ito na siyang i-differentiate with respect to the three variable. So, partial of by the way, kani squared naman mo na ni ang sub r or sum of the square of residuals. So, may mo na ni partial of s sub r with respect to a sub o. So, with respect ani, may mo na ni 2 summation of y minus AO minus a1x a sub 2 x squared times 1. Okay? So, more na siya. So, again, equate this to 0. Have 0 is equal to summation of y minus summation of AO summation of a1x minus summation of a2x squared. Differentiate s sub r with respect to a1. Again, you will get this one, summation of y okay. By the way, label na to as equation 1 times respect to a1 times x. Okay? And then, with 0 summation of xy minus summation of AOX minus summation of A1 x squared summation of A2 x cubed. Okay, this is your second equation. Partial of S sub r with respect to A2. You'll get to summation of y times respect to a sub 2 times x squared. Equate to 0. You'll get summation of x squared y minus summation of a squared summation of a1 x cubed minus summation of a2 x to the fourth. This is your third equation. Okay? Here's one. So we now have 3 equations and 3 unknowns. We will rewrite this one. So this becomes summation of a sub o. Now ang summation of a sub o from 1 to 10, again, this is just equal to n times AO plus because plus summation of x a1 plus summation of x squared a2 is equal to summation of y. Okay, so that is your first equation. Second, this one becomes summation of x times AO plus summation of x squared a1 plus summation of x cubed a2 is equal to summation of, and then the third equation, this one, that's summation of x squared AO plus summation of x cubed A1 plus summation of x to the fourth A2 is equal to squared y. Okay, so you now have these three equations. So again, you can use Kramer's rule to determine the value of AO, A1, A2. Okay, we can use that one. Or, pwede na po kanya itong gamiton. No? So, sa atong example, ito ni-plug in yung mga value ani, we'll arrive at 3 equations, 3 unknowns, and then apply either Gaussian elimination, no? In order to determine AO, A1, and A2. Okay? So, let's have an example. Okay? Let's have this example. Okay, so this is our example, and we have value for x and y. So the first thing that we'll do is to check whether we can apply linear regression. Okay? So ato ni siyang i-graph. No? We have y. We have 1, 2, 3, 4, and 5. And for this one, we'll use by 10. No? 10, 20, 30, 40, 50, 60. Okay? So 0, 2.1, mga dere. 1, 7.7, 3, 2, 13.6, 3, 27, 4, 40, and 5 is 61. Okay? So, it is apparent that we cannot use linear regression because paano ang graph sa atong points. So, we will use polynomial regression. Okay? So, based sa atong equation, if I write again our equation, NAO plus summation of x A1 plus summation of x squared A2 is equal to summation of y, and then summation of x AO plus summation of x squared A1 summation of x cubed A2 is equal to summation of xy. Okay? So you have summation of x squared A2 okay? So muna siya. So what na to, again, we will pangkuha na ni x squared, x cubed, the fourth. So you have x squared, x cubed, x to the fourth. Then you have xy. You have also x squared y. Okay? So, summation of x, isama to na yung 1, 10, 15. Okay? Kani, pila man na siya. Kani, summation 152.6. Okay? And then, x squared, so 0, 1, 4, 25. Summation of x squared is 55. Okay, 25. 45, 46, 55. Okay? And then x cube times 8, 7, 16 cube. Okay? 4 cube is 64. 5 times 5, 125. Okay? And then 0, 1, 16, 81, 256, right? Therefore, summation of x cubed is 2 to 5. Summation of x to the 4th, 79. Then xy, 7.2, 1.6. Okay? And then you have x squared times y. So, 7. Okay? The summation of xy is 585.6. Summation of x squared y is 288.8. Okay? So since we have these values, we will plug in these equations and we can get three equations, three unknowns. Okay? So you have n. Our n is, pila itong n? 1, 2, 3, 4, 5, 6. We have 6. By the way. 6. Summation of x is 15. Summation of x squared, 5. 15. And then summation cube is equal to summation of y 5, 5, and 4, 8, 8. Okay? So, we now have three equations, three unknowns. And then, what you're going to do next is use either Gaussian, Gauss-Jordan, whatever method that you prefer. So, using those processes, can arrive at the value of AO, which is 2.47857. A1 is equal to 2.35929. And then 1.86671. Okay? And plug these values in the equation. So you have y is equal to 2.47857 plus 2.35929x plus 1.86x. Okay? So that is how you get the equation for the data, no? Second order regression. We now have determined the second order curve that will represent this data. So actually there is a parameter which is called the standard error of estimate. So basically this parameter tells us the standard deviation of the line. Okay, so the general equation for the standard error of estimate is this one, denoted by S subscript y over x square root of SR over n minus m plus 1. So the n is the total number of data. So in this case, 1, 2, 3, 4, 5, 6. So 6 data points minus m plus 1. Now this m is the this one, the exponent of the line, the largest. Okay, in this case this is a second order curve, so the m is 2. Okay, m is 2. If this is linear, so kaning m will become 1. So may meaning SR over n minus 2, which is the equation for the standard error for linear equation. So this parameter tells you the uh, standard deviation, so meaning the spread of the data with respect to the line. It will tell you how large or how small is the difference between their values compared to the value in the line. Okay, so kuha na to na. That is just SR. So sum of the squares of residual. So this one, 3.74657 divided by 6 minus 3. Square root, get 1.12. Now, if you want to get the coefficient of determination, the equation is, again, r squared is just st minus sr over st, wherein st is the difference between the value and the mean. Okay? Tama na siya. Which is 0.99851, or the correlation coefficient is 0.99925. So these results indicate that 99.851% of the original uncertainty has been explained by the model. So these results support the conclusion that the quadratic equation represents an excellent fit. Okay, so the value of r squared, or the coefficient of determination, is very close to 1. So it denotes a good, very good fit, excellent fit. Okay, for the pseudocode, you can find it here, figure 17.13 for polynomial regression.